Hello, welcome students. And in the previous lectures we are discuss. Let's start to discussions of the propagations of electromagnetic waves. And one types of the propagations we are discussed the ground waves propagations or surface wave propagations, when the waves which can be start to traveling very closer to the earth surface. And we have discussed the same heading, same points, and different types second types of the propagations of the waves, that is propagation of EM wave, propagation of electromagnetic waves. In the previous lectures we have discussed the radio waves, how to propagate over the closer to the earth surface, and discuss the different types of the atmospheres, the range of the atmosphere, how to calculate. I will discuss here how to calculate the range of the atmospheres. This is the 20, 50, 85, and this is also thickness, but the 50 is not a thickness of the second sphere. We have calculated the thickness of the second sphere. Will be discuss the between boundary conditions. Okay, this is one of the examples we are discussed here for the consider for the calculating of the thickness of particular atmospheric around the earth surface. In these lectures we are discuss the second type of the propagations of the electromagnetic wave, that is space wave propagation, that is space wave propagation, space wave propagations, space wave propagations. Then in the previous lectures we have discussed the ground wave propagations, and frequency is less than 2 megahertz, and this is some limitations of the uses of that propagations. In these lectures we are conclude the uses and discuss the different types of the uses, and in the next lectures we are discuss the third and important types of the propagations of electromagnetic wave, that is sky wave propagation, and we are finished the electromagnetic waves. This is the types of one of the types half portion of the topics, that is not half, 75% of the topic will be finished, and last will be communication system here discuss here. But let's start to discuss the space wave propagations. Waves from the transmitter antenna to the receiving antenna, it reach either directly along the straight line, it either reaches directly along the straight lines, or it can be reflected on the ground surface. Space पासून एखादी वेव जर येत असेल, consider this is the earth surface आहे, okay, and स्पेस मधून एखादी जर अर्थ सरफेस येत आहे, एखादी वेव्स येत आहे, कन्सिडर दिस इज अ रिसिविंग अँटेना, द डायरेक्टली एकतर डायरेक्टली येऊन रिसिविंग अँटेनाला हिट होणार, और दे आर रिफ्लेक्ट होत आहे, किंवा अशा पद्धतीने रिफ्लेक्ट होणार आहे ऑन द सरफेस ऑफ द अर्थ, ऑन द ग्राउंड सरफेस. वेव्स फ्रॉम, लेट्स राइट द पॉइंट्स, वेव्स फ्रॉम transmitting from sphere, they reach to receiving antenna either straight line, I will be drawn of the different diagram, that is like this, either straight line or reflected on the ground. And when they are reflected from the ground, the spheres which will be present closer to the earth surface is tropospheres, which can be range is 20 km. We are discussed in the previous lectures. Okay, then when they are reflected from the earth's surface, they will be indirectly reflected from the tropospheres. They will be indirectly reflected from the tropospheres, and these waves which are reflected from the tropospheres are called tropospheric wave. Tropospheric wave. Okay, what are the discussions in this lectures? That is space wave propagations. Waves from the transmitting पॉइंट, एखाद्या ट्रान्समिटिंग पॉईंट पासून एखादी वेव्ह येत असेल, एखाद्या रिसिव्हिंग पॉईंटला जर रीच होत असेल तर आयदरली डायरेक्टली तर रीच होते किंवा एखाद्या अशा पद्धतीने रिफ्लेक्ट होऊन तरी रीच होत असते किंवा त्या ठिकाणी पोहोचत असते. द फ्रिक्वेन्सी जी काही रेंज होती ग्राउंड वेव्ह प्रोपगेशन्स आपण बघत असताना फ्रिक्वेन्सीची रेंज जी काय होती, इट इज लेस दॅन 2 मेगाहर्ट्ज, बट द फ्रिक्वेन्सी रेंज ऑफ द स्पेस वेव्ह प्रोपगेशन्स इज मोर दॅन the frequency is more than 30 megahertz. 30, please remember for the MCQ, the frequency range of the space wave propagations is more than 30 megahertz. In the MCQ they will be asked less than 2 megahertz, more than 30 megahertz, more than 2 megahertz, greater than 60 megahertz. It is some MCQ options will be give you, but the right answer will be more than 30 megahertz. Then, but this is not possible. Okay, these waves can't propagate in a space. These waves can't be propagated in space, but excepting when we are using the satellites, by using of satellites, the TV signal which have the high frequency, TV signals which have high frequency range, the TV signal which have the high frequency, they're transmitting over the long distance. Over the long distance. एखादे टीव्ही सिग्नल जे काही एखादी क्रिकेट मॅच असं आपण बघत असताना दिस टीव्ही सिग्नल जे काही सिग्नल्स येत असतात ते क्रिकेट मॅचच्या ब्रॉडकास्टिंगसाठी इट इज कम्स फ्रॉम द लार्जर डिस्टन्स, दॅट इज लार्ज स्पेसमधून किंवा सॅटेलाइट्समधून ते येत असतात. तर द टीव्ही सिग्नल त्याची फ्रिक्वेन्सी हाय असते आणि ते कम्स टू दी हाय लार्जर डिस्टन्स. इट इज नॉट पॉसिबल, आणि हे पॉसिबल नाही आहे. केव्हा पॉसिबल होत असते? स्पेस वेव्ह प्रोपगेशनमध्ये पॉसिबल होते. इट इज पॉसिबल इन स्पेस वेव्ह प्रोपगेशन. स्पेस वेव्ह प्रोपगेशन मध्ये पॉसिबल आहे. ओके, ग्राउंड वेव्ह प्रोपगेशन इट इज नॉट पॉसिबल बिकॉज द लाइट द वेव्स विल बी कम्स फ्रॉम द स्पेस and this will be not possible in a ground wave propagations. The next point, the maximum distance over which the waves will be reach, the kitty maximum distance, the maximum distance over the signal over which signal reaches, or the maximum distance over which the signal can be reached are called range, and it is range will be denoted by d. D is a distance, maximum distance which will be reaches by the waves. For the large TV signal, जर एखादी large coverage पाहिजे असेल, TV signal जर coverage large पाहिजे असेल, for the large coverage TV coverage, for the large TV coverage, the height of receiving antenna as large as possible, जी काही टीव्ही कव्हरेज जर जास्त पाहिजे, फॉर द हाय टेलिव्हिजन कव्हरेज द हाईट ऑफ द रिसिविंग अँटेना इज more larger. Receiving or transmitting antenna will be larger, maybe transmitting or always receiving antenna is larger as possible. Then we are see the towers will be more distance or more heights. Okay, ठीक है. Then the range is a straight line distance. What is the range? Range is a straight line distance from the point from the waves will be transmitted. I will be right here for the same. The range is straight line distance. The range is a straight line distance from the point of transmitting, from the transmitting point of transmitting signal and the waves hits a point on the earth surface, What is the distance? What is the range? The main point, what is the range? Range एक straight line distance. It is a straight line distance from the point of the transmitting. एखादी पॉइंट आहे ट्रान्समिटिंग सिग्नलचं जे काय पॉइंट आहे त्या पॉइंट पासूनचे जे डिस्टन्स आहे एखाद्या अशा पॉइंट पर्यंत किंवा एक अशी पॉइंट ज्या ठिकाणी एक वेव्स हिट होत असते ऑन द सरफेस ऑफ अर्थ. ओके, या ठिकाणी आपण डायग्रामॅटिक रिप्रेझेंटेशन बघण्यासाठी थोडासा I use these portions of the boards. Then before the rubbing of this I will just revise it. Waves from the transmitting spheres, from the spheres, they reach us, not a sphere, that is from the space. From the space they are the reaches receiving antenna, either straight line or reflected, either straight line or the reflected on the ground. And the waves which can be reflected, these waves which are reflected from the tropospheres, this is called as tropospheric waves. The frequency of that particular wave which can be passes from the space, they are propagated in the space, the frequency is more than 30 megahertz. The TV signal which have the high frequency, they transmitting over a long distance space is propagated. Okay, long distance it is not possible when they are follow or they are passing closer to the earth surface, then we are use the space wave propagations. The maximum distance over which the signal can be reaches, the maximum distance over the signal which can be reaches, this maximum distance is called as a range, and we are denoted this range by small d. For the large television coverage, the height of the receiving antenna, or I will be use here transmitting antenna, as large as possible. Okay, as large as possible. The range is the straight line distance. The range is a straight line distance. I will be only use here transmitting. Okay, transmitting. Okay, the range is the straight line distance from the point of the transmitting signal, and the waves which can be hit on the points on the surface of earth. Okay, on the surface of earth. But we are start to discussions what are the d, that is range, and how they are calculated of the d's, and we are start to derive the formula for the calculated of the d, that is the range. Range is the maximum distance over the waves, how can I reach, what is the distance to reach of that particular waves. Then consider this is earth. This is not exactly earth, but we are consider this is the earth. This is the transmitting signals. Okay, I will be write to different parts. This is the transmitting signals, and this is the point of the transmitting. I will be denoted as a bar, and this is the another, that is the c bar. Okay, and the point, what is the range? The range is a straight line. This is the straight line. The range is a straight line from the point of the point of the transmitting signal. This is the point of transmitting signal to the waves which can be hits on the point on the surface of the earth. This is I naught b, and this is called the distance d, and distance, it means the range distance d, and this is the d dash, and this point will be, I consider a, and this is another one point, that is c here, and this is the center of the earth. But any lines which can be passes tangent to the surface of the circle, consider the earth will be circle, earth is one of the circle, and any points which we passes through the tangent to the surface of that circle, सर्कलच्या एखाद्या टँजंट मधून एखादा लाईन पास होत असेल तर ती लाईन त्या सर्कलच्या रेडियसला, त्रिज्याला परपेंडिक्युलर असते, अँड दिस इज द OB इज अ परपेंडिक्युलर टू द A dash and C dash. Then I will be write this is the straight line distance here. Okay, diagrammatic representation थोड़ा चुकला असेल, this is my fault, but these are the straight line, and this is the R, radius of the earth, and this is also R, this is also R, but A dash to O, the distance is A dash, A dash जे का है A dash, it is the height of transmitting signal, transmitting antenna. A dash is the height of the transmitting antenna, that is denoted as a small h. Then this is a D, this will be H, this is the H, and this is the R, and this will be R, that is the radius of the earth surface. And what I do here, you will be concentrate, this is the right angle triangle, that is A dash O and B, A dash triangle, A dash O and B is a right angle triangle. Okay, right angle triangles. We are studied the Pythagoras theorem in a childhood, that is the square of hypotenuse is, that is A dash O square is equal to, A dash O square is equal to A dash B square, A dash B square plus A dash B square is one side and another is the OB square, OB or BO squares. We know that OB or BO, it is the radius of the earth, and I will be the here for the okay, let's start. Then that is A dash O. A dash O is the additions of A dash A plus AO. AO is the R and A dash A is the height. Then for the left hand side, that is A dash O is H, A dash A is H, plus AO is a R, that is the radius of the earth surface, that is square, equal to A dash B. A dash B is the distance D, that is D square, plus BO square. BO square, it is R square. And here I will be use one of the mathematical property, that is AB square. A plus B bracket square is equal to A square plus B square plus 2AB. I will be this same property I will be use here, that is H square plus R square is equal to plus 2RH. H square plus R square plus 2RH is equal to D square plus R square. We are seeing the same point, same terms in the both sides of the equal signs, that is R square and R square. I will be cancel here. The R square and R square is cancelled for the present in the different sides of equal signs. Then what is remaining? H square plus 2RH equal to D squares. The H squares is, or H is much more less than R. Then I will be neglected here. एखादी स्मॉलेस्ट व्हेरी स्मॉलेस्ट टर्म एखाद्या मोठ्या टर्ममध्ये ॲड केल्यानंतर त्या मोठ्या टर्ममध्ये काहीसा इफेक्टिव्ह चेंजेस होत नाही, त्यामुळे हे काय करणार आहे मी निग्लेक्ट करणार आहे, बिकॉज इट इज व्हेरी स्मॉलेस्ट. Then the D is equal to under root 2R plus H. Why I will be use under root? Because this is the square and I will use square root. That is D is equal to under root 2R H. We write the proper. That is D is equal to under root 2RH. This is the formula for the calculating of range of the particular signals that comes from any transmittings. What are we doing? Let's discuss here. The range, it is the distance, straight line distance from the point of the transmitting signal, to the at the point which can be hits on the surface of the earth of that waves. And this is called as D. We are calculated the distance D, and I will be used one of the transmitting signal, that is AA dash. The distance or the height of the AA dash will be H. The total height of that points which can be received, which can be emit or transmit the signal waves, this is from the center of the earth, is R plus H. The R is the radius of the earth and H is the height of that antenna, transmitting antenna. Then I will be use this properties of the circles. The tangent lines of the circle which can be passes on the circumference of the circle, these are also perpendicular to the radius of that circle. This is I property uses here. Then this A dash O and B are the right angle triangles, and I will use the Pythagoras theorem, that is A dash O square plus A dash B square, that is D, plus BO square, that is R, I will be used here. And one another mathematical property, use A square plus B, A plus B bracket square is equal to A square plus B square into plus 2AB. This is used here in the form of H plus R bracket square. H square plus R square plus 2RH equal to D square plus R square. In the equal part are present in the different sides of the equality signs, I will be cancel here, that is r square will cancel, and remaining term, that is h square plus 2rh is equal to d square. So the h is very negligible or very small as compared to r, and then this will be adding in the terms of the r, कॅन्सल हिअर और निग्लेक्ट. एखाद्या मोठ्या टर्म्स म्हणून छोटासा टर्म ॲड झालेला असेल तर तो जास्त इफेक्टिव्ह नसल्यामुळे आपण काय केलं या ठिकाणी आर स्क्वेअर निग्लेक्ट केलेला आहे. कन्सिडर एखाद्या वेळेस जर एच हे 0.01 असेल तर त्याचा स्क्वेअर 0.001 असणार आहे. देन ही इतकी छोटीशी टर्म्स या मोठ्या आर इतक्या डिस्टन्समध्ये ॲड करणं काय इफेक्टिव्ह नसल्यामुळं आपण काय केलं, एच निग्लेक्ट केला. देन द डी इज इक्वल टू 2r प्लस एच. दिस इज द ऑल अबाउट the space wave propagations, the space wave propagation. In the next lectures we are discuss the sky wave propagations. Before the discussion you will be solve some problems on these points or these formulas.